So we have this problem here that deals with weight percent. We see a bottle of bleach contains 5.25% by weight sodium hypochlorite. The remainder is going to be water. So it's an aqueous solution. How many grams of chlorine are in 500 grams of bleach? Well, let's remind ourselves of the definition of weight percent. These are obviously going to be important. The definitions of all these concentrations are going to be very important. So weight percent is going to be the grams of your substance of interest, which in this case is sodium hypochlorite, for every 100 grams of the solution, which in this case the solution is bleach. Bleach contains water as the solvent and sodium hypochlorite as the solute. This 5.25% tells us how many grams of sodium hypochlorite we have in this 100 grams of bleach, so I can write 5.25 grams of sodium hypochlorite for every 100 grams of bleach. Now we're trying to find how many grams of chlorine are in 500 grams of bleach. We know how much there is in 100. So let's just multiply this by 500, right? This fraction here, if we multiply this by 500 grams of bleach, then we find, as this cancels, well, not the 100, but the grams of bleach will cancel. And we'll find how many grams of sodium hypochlorite will be in the 500 grams of bleach. 5.25 times 500 divided by 100, 26.25 grams. That is going to be our grams of sodium hypochlorite in our 500 grams of bleach. But the question asks not for grams of sodium hypochlorite, but rather for the grams of chlorine. So we're going to have to do some more calculation here. 26.25 grams of sodium hypochlorite. We're going to convert that to moles. So I'm going to convert grams of sodium hypochlorite to moles of hypochlorite, because I know that for every mole of sodium hypochlorite, there's 1 mole of chlorine. And then, of course, 1 mole of chlorine will tell us how many grams of chlorine we're going to have. So I got to figure out the molar mass of both chlorine and sodium hypochlorite. We can figure that out by looking at the periodic table, and we'll get these values. For sodium, you're going to find that's 23 grams in a mole. For oxygen, there's 1 of those. We're going to find that 16 grams per mole. And for chlorine, that's going to be 35.45 grams per mole. We add all that up. Let's see, 3, 6 is 9. That's 14. Carry the 1. 1, 2, 3, 4, 5, 6, 7. 74.45 grams of sodium hypochlorite in a mole of sodium hypochlorite. And of course, here we know that there's 35.45 grams of chlorine in a mole of chlorine. So now all that's left is to do this arithmetic. We take our 26.25. We're going to divide that by 74.45. We're going to 1 and 1. We're going to multiply that by 35.45. And then we have our answer, about 12.5 grams of chlorine total in every 500 grams of bleach. Okay, now we're going to do a problem that deals with mole fraction. We're going to take our same bottle of bleach that contains 5.25% by weight sodium hypochlorite, and then we're going to ask ourselves, given this, what is the mole fraction of water in the bleach? Let's remind ourselves what mole fraction is. In this case, we want the mole fraction of water, and that's going to be the moles of water divided by the total moles in the solution. So in the solution, we're going to have both water and sodium hypochlorite. So we see that to calculate the mole fraction, we're going to need to know how many moles of water are contained in the bleach and the moles of sodium hypochlorite in the bleach. Now, since this is a fraction, we can just assume any amount we want. It's easiest to just assume that we have 100 grams of the solution, because we might remember that the weight percent definition is going to be the grams of our substance of interest, which in this case, if we're talking about weight percent, the 5.25% refers to the sodium hypochlorite. So I can write 5.25 grams of sodium hypochlorite for every 100 grams of the solution. Well, let's remember that the solution is the solute. There's only one solute in this case, plus the solvent. The solution is 100 grams total. The solute is 5.25 grams. And then we can figure out the grams of water that are present. It's just going to be the difference. So, of course, 100 minus 5.25 will give us 94.75. That's going to be our mass of solvent, which is water. So now I have my grams of water for every gram of sodium hypochlorite. I can convert these to moles. Then we can pop them in this fraction here. Let's start with the sodium hypochlorite. We have 5.25 grams of it. And I know that there are 74.45 grams of sodium hypochlorite for every mole of sodium hypochlorite. So this will help us calculate our moles of sodium hypochlorite. 5.25 divided by 74.45. There's our moles of sodium hypochlorite. See our moles of sodium hypochlorite? We'll put 0.071 moles. For water, we're going to do the same thing, but for water, we have 94.75 grams. 94.75 grams of water. And we remember for every 18 grams of water, that's a mole of water. So we're going to take our 94.75 and we're going to divide that by 18. There's our moles of water, 5.26. So I'm going to pop that in up here and also down here. The denominator is going to be the sum of these two. So 5.26 plus 0.071. So that denominator total is 5.33 moles. So our mole fraction of water will be 5.26 moles divided by 5.33 moles. And our mole fraction of water, in this case, in the bleach that has 5.25% by mass sodium hypochlorite, looks like it's going to be 0.987. That's our mole fraction of water. And it's pretty easy to figure out what the mole fraction of the sodium hypochlorite would be, because these are the only two substances present. So this is just going to be 1 minus this. I'm going to make this negative, add it to 1. Your mole fraction of sodium hypochlorite in the bleach is going to be 0.013. And if we wanted to write these as percents, this would be 98.7% of the moles come from water, and 1.3% of the moles come from sodium hypochlorite. All right, now let's do a problem with our third unit of concentration, which is molarity. We'll start once again with bleach. which we remember contains 5.25% by weight sodium hypochlorite. And we want to know what's the molarity of sodium hypochlorite in bleach. And we're given the density. Let's remind ourselves what the units of molarity are. The units of molarity are going to be the moles of the solute, which in this case is sodium hypochlorite, for every liter of solution, which in this case is bleach. Bleach is sodium hypochlorite and water. The units we're given are going to be grams, which is 5.25%, grams of sodium hypochlorite for every 100 grams of solution. Here's the units we have, grams of sodium hypochlorite on the numerator, but we want moles of sodium hypochlorite on the numerator. Also, we have grams of solution on the denominator, whereas we want liters of solution, bleach is the solution, on the denominator. Let's attack the numerator first. That's fairly easy if we remember that the molar mass of sodium hypochlorite is 74.45 grams in a mole. So this step here allows us to convert the numerator from grams of sodium hypochlorite to moles of sodium hypochlorite, which is what we want. Now all we need to do is convert the denominator from grams of solution to liters of solution. This is where the density is going to come in. We want grams to liters. Here we can get grams to milliliters. So let's do that here. We want to cancel grams of the solution on the denominator. So I'm going to put grams on the numerator. And we want liters on the denominator. Well, we can get milliliters through the density. So we know there's 1.01 grams of sodium hypochlorite for every, grams of the solution, which is the bleach, for every milliliter. Then, of course, to get that to liters, there's 1,000 milliliters in a liter. That's it. I think we've done it. I think at this point we can run through the calculation. Let me just cancel out the units just to make sure. Grams of sodium hypochlorite cancels grams of sodium hypochlorite. Grams of solution cancels grams of solution. And it looks like I have moles of sodium hypochlorite that are surviving for every liter. Moles per liter, that's what we want. So now it's just doing the arithmetic. 5.25 divide by 100 divide by 74.45 times 1.01 times 1,000. So it looks like bleach is roughly 0.71 molar in sodium hypochlorite. Okay, now we're going to do a problem that deals with molality, which we'll remember the definition of molality. We abbreviate it with a little m. That's going to be the moles of our solute for every kilogram of solvent, not solution, solvent. And we're going to remain with our concentration of bleach here, 5.25% by weight, sodium hypochlorite. What's the molality of sodium hypochlorite in the bleach? So we can write that we know that we have 5.25 grams of sodium hypochlorite for every 100 grams of bleach. We get this from the definition of weight percent, grams of solute for every gram of solution. We're going to need to convert the numerator to moles of sodium hypochlorite. And we're going to need to convert the denominator from grams of bleach, which is grams of solution, to kilograms of solvent. Now, how are we going to do that? We got to get solution to solvent. Well, let's remember this equation, that the solution is the solute. In this case, there's only one, plus the solvent. This ratio here is going to help us because I know that for every 100 grams of my solution, I have 5.25 grams of the solute. And the remainder is going to be the solvent, which is what we want up here. Well, 100 minus 5 1/4, that's 94.75 grams of our solvent. So we can write then that we have 5.25 grams of sodium hypochlorite for every 0.09475 kilograms of water, which is our solvent. Notice what I did here. I converted grams to kilograms. That's the trick that's going to help you get from solution mass to solvent mass when dealing with molality problems. This equation here. Now my denominator's right. All I got to get is my numerator correct, and we know how to do that because we're going to remember that the molar mass of sodium hypochlorite is 74.45 grams sodium hypochlorite for every mole of sodium hypochlorite. So I've converted my grams of sodium hypochlorite to moles of sodium hypochlorite on the numerator. My units now are going to be moles of my solute per kilogram of solvent, which is what we want. And now that's all that's left to do is the arithmetic. 5.25 divided by 0.09475 divided by 74.45. We would have a 0.74 molal, so 0.74 molal solution. That's the way it's said, molal. For molality,